Fractalic is a programming language and platform designed to quickly create AI workflows and agents using simple, natural language structured in Markdown and YAML. Your projects are stored in clear, easy-to-read text files that also function seamlessly as interactive notebooks, making it easy to define contexts, instructions, and logical flows intuitively. When you run workflows, Fractalic clearly shows each step the AI takes, making it easy to follow along and understand what's happening. Every run is automatically saved to Git, keeping your projects organized and transparent. Fractalic connects effortlessly to external services and cloud APIs, making it ideal for rapidly developing SaaS solutions and product prototypes. It allows you to easily switch between different AI models or have multiple models collaborate in the same workflow. Instead of dealing with complicated Python frameworks or confusing node-based editors, Fractalic lets you directly interact with AI using plain language, making your prototyping and building processes fast, simple, and intuitive. Let me explain how Fractalic works. At its core, it's built on a Markdown file that actually functions as an executable. What happens is, when the system starts up, it takes this file and loads it into memory as what we call an execution context. Then the interpreter goes through and analyzes everything in the file. It breaks down the content into two main types of blocks. You've got your regular Markdown blocks with headings, and then you've got these special instruction blocks. You can spot these instruction blocks because they start with an @ symbol, followed by an instruction name and some YAML parameters. After it finishes parsing everything, the sequential execution begins. When the interpreter encounters an operation, such as making an LLM call, it collects the current prompt along with all the previous knowledge blocks, combines them into a single text, and sends that to the language model. When it receives a response, which typically includes a response header for consistency, it adds that response to the context immediately after the operation that initiated it. As execution continues to the next operation, all those previous blocks, including any newly generated responses, become part of the context for subsequent operations. This is essential because it allows each step to build upon what came before. When execution completes, the system compiles all these blocks and saves them to a result file. This file maintains the same name as the original but uses a .ctx extension instead. Both the source file and this context file are stored in a Git repository in a new branch. Since each execution session creates its own branch, you end up with a clear history of all your execution paths. Fractalic leverages Markdown's heading levels system to create hierarchical document structures that are represented internally as trees. The standard header syntax determines how deep something is nested, and we can give blocks specific identifiers using a special syntax like an ID attribute set to block identifier, enclosed in curly braces. If we don't explicitly assign IDs, the system just automatically creates kebab case identifiers from the headings. Any block can be referenced in operations using the block parameter with its ID. The system handles not just individual blocks, but also arrays of blocks using YAML syntax. For hierarchical operations, the / and asterisk lets us select entire branches, the target block plus all blocks with lower nesting levels. The interpreter also supports referencing blocks by their full path in the tree hierarchy. Let's look at a specific example. A branch rooted at nested block 1 contains text with those 3 dots that need to be replaced with model-generated content. First, we specify the block as a branch, then process it through the language model to get a response. By default, this creates an LLM response block, but we can override this with the Use Header field. Setting Use Header None removes header generation completely, allowing for seamless replacement. For content manipulation, Fractalic offers 3 main modes: Replace, Prepend, which inserts before the first block in a branch, and Append, which adds after the last block. In our example, the identifiers stay the same because the headings haven't changed. The system includes a notebook-style UI for visualizing hierarchies, adding operation nodes, and configuring the many available parameters. This interface makes it simple to run files and compare the source with post-execution states through diff views. One of Fractalic's most powerful features is the run operation, which launches separate workflows or agents in isolated execution contexts. Let me give you a brief example: a script to recommend clothing based on current weather. The run operation launches a module in a completely isolated context. The language model only sees content relevant to this specific execution. The source parameter, prompt, gets passed and inserted at the beginning as input parameters. What's particularly cool is the ability to generate operations dynamically. Since we don't know ahead of time what instructions we'll need for weather-checking shell operations, we tell the LLM to generate these operations based on user input. By using useHeader_none, we prevent default header generation, which lets the generated instruction be interpreted directly as an operation. The result is a shell operation that calls a weather service, something like wttr.in. This executes, and the std_out response, along with std_dir if there is any, gets inserted as a block in the answer. Since the final operation is returned with an explicitly specified block, this weather information gets inserted into the source file's context, allowing the model to make an informed clothing recommendation. When execution involves nested calls, each executable file and its .ctx result are linked together in a hierarchical structure saved to Git. When working with language models in Fractalic, we can include any type of media supported by the model and provider using the media field, which also accepts multiple files as an array. If we want an AI to analyze an image, we simply include the file name, and models like Claude will immediately describe what they see. Beyond images, we can work with any format our chosen model supports. For instance, we can send Anthropic models a PDF document for summarization, and the key information returns directly to our context. Fractalic lets us customize each operation in detail. When calling language models, we can adjust settings like temperature based on our task. For creative work like joke generation, we might increase it. And we can set system-wide default settings. I actually recommend always keeping it equal to 0. We can specify different providers directly in our workflow. We have Anthropic Claude Sonnet now selected as default for every LLM instruction. And for instance, we might indicate OpenAI as a provider, but use DeepSeek R1, a reasoning model, by configuring the base URL in our global settings. In one workflow, we can start with Claude, switch to DeepSeek, and finish with any of Grok's models at a higher temperature, like having different AI models create jokes and then picking the funniest one. Let me walk you through an image generation example using a cloud model service like replicate.com. We begin by calling an agent with our image description. The agent uses the import operation to load specific documentation into the context, and in this example, we're not going to load the entire file, just the block with a brief explanation of how to use replicate.com's image generation service. Next, we call our tool with the help parameter, which loads all available options into the context. Providing help sections in your CLI tools is a good practice, as this gives the model a complete understanding of the parameters it can use. Following the loaded instructions, the model generates the exact command needed, inserting all the right parameters for the tool. For external services that require authentication, Fractalic lets you specify environment variables in your settings. These are automatically applied to the execution session, whether configured through the UI or in configuration files. This approach enables smooth integration with any external API or service. After generating the image, the result is saved to your specified folder. Since we're often developing and testing, we can instruct Fractalic to generate a Markdown or HTML block that displays the image directly in your document preview. No need to search through folders. The server handles rendering these images. You just specify the resource path. The system's Markdown viewer supports rich formatting, including tables and mermaid diagrams. For example, you can create an external agent that analyzes previous runs, displaying all parameters and execution steps in an easy-to-read format. This gives you detailed analytics of your workflows, showing execution parameters, visualizing the structure using Git branch snapshots, and creating sequence diagrams with all the parameters passed during execution. These generated workflow reports aren't just for humans. We can feed them back later to models for error correction or process improvement. Fractalic brings together flexible media handling, multiple AI models, external service connections, and clear visual analytics, all while keeping everything in a readable, trackable format that both humans and AI can work with. The system is completely open source and free. Thank you, and see you in our next tutorials.